So the topic for today is solving equations that contain radicals. All right, and so there's two types of equations we're going to learn to solve. One is a radical equation, and a radical equation right here is solving an equation with x in the radicand. And what that means is under the radical sign. So that's where x is. All right, so in other words, you're going to have something like this in your equation. That's what a radical equation is. We're also going to solve linear equations. And linear equations are equations that have square roots in them, but x is not under the square root. So here we have linear equations, and what this means, x is in front of the radical sign. So something like this. All right? There is a square root, but x isn't under it. X is out in front of it. Two different types of equations and two completely different methods for solving them. All right, so we've got to keep those two methods straight. So first of all, let's go back to radical equations. And we talked a little bit about how to solve these before, but we're going to do ones that are a little bit more difficult. First of all, solving by squaring both sides is the method we're using. Remember the golden rule of algebra, do unto one side what we do unto the other? And one of the things we learned at the beginning of our radical unit was one way we could solve an equation is to square root both sides. Well, now we're going to solve an equation by squaring both sides. All right? And so the method for doing this includes two steps. First of all, isolate the radical term on one side. And what that means is get the radical term all by itself on one side. Then square both sides. And if it's a cube root, you would cube both sides. So raise both sides to the power of 3. All right? Now here's an unfortunate thing about this type of problem and this method. Note, squaring both sides of an equation may create extraneous solutions. So you must check your answers in the original equation. And you know how to do that. You just plug your answer into the original equation and see if it works. Well, here's what an extraneous solution is. Extraneous solutions are solutions that you get when you solve an equation that really do not work in the original equation. So all they are is extra solutions that come out of the process of solving an equation, but they don't work. They don't work in the original equation. All right, so when you use this method, you have to check your answers. You will get extraneous solutions a lot. All right, it's not once in a while, it's a lot. All right, so keep that in mind. So our first equation is the square root of 2x minus 1 equals 3. Now, I have the radical term, which is this, all by itself on one side. Okay? My next step, to get rid of the square root, I'm going to square both sides. Just like this. All right? When I square a square root, remember from last week, what this means is I get 2x minus 1. The squaring and the square root cancel each other out. All right? And 3 squared equals 9. So let's add 1 to both sides. And I get 2x equals 10. Divide both sides by 2, and I get x equals 5. All right? But I want to make sure that I check my solution by plugging it back in, because I want to make sure it's not extraneous. So 2 times 5 is 10, minus 1 is 9, the square root of that is 3 equals 3. So both sides are the same, and this is not an extraneous solution. This is a good solution. Okay, let's go to example B, and we have actually a cube root in this problem. So the method to solve this is to cube both sides. So first of all, we need to get this radical term all by itself. Okay? So add 1 to both sides. And so I have 2 times the cube root of x equals 4. Now, I've got the radical term all by itself, so I can cube both sides. But in this particular instance, I noticed something really interesting. I could easily divide both sides by 2, right? And that would just make my problem easier. You won't always be able to do that, and that's fine. You can leave that there. If you cube it, you'll get 8. So let's divide both sides by 2. And that's going to give us the cube root of x equals 2. And our method to solve this is to cube both sides. When we cube a cube root, it cancels it out, and we have x equals 8. We want to check this solution. So let's go ahead and plug it in. The cube root of 8 is 2, times 2 is 4, minus 1 is 3, and that's what we've got. So it works. So I'm going to go ahead. This is a good solution. All right. This next one is a little bit more complicated because it doesn't just have a square root of x. It's also got this over here. All right? So here's what we're going to do. We've got to get that radical term. That's this, all by itself. So subtract 3x from both sides. And what I've got here is negative 5 square root of x equals 2 minus 3x. All right, I don't want to divide both sides by 5 necessarily. There's really no need to do that. It's not going to divide out nicely. It's part of the radical term. It's okay to be there. All right, our next step here is we are going to square both sides, and that's going to get rid of our radical. So put this side in parentheses and square it. Put this side in parentheses and square it. All right, when I square negative 5, I've got negative 5 times negative 5. That gives me 25. Square root of x squared cancels that out, so I just have x. And on this side of the equation, what I need to do is FOIL. All right, so 2 times 2 is 4. 2 times negative 3x is minus 6x. I'm going to do the inners, and I'm still going to get minus 6x again. And then negative 3x times negative 3x is plus 9x squared. All right? Now we're going to use a skill that you learned in Algebra 1, and we're going to solve this equation. All right? So the next thing I want to do, to solve an equation where I have x squared, get everything on one side so you have 0 on the other side. We did this in Algebra 1. So here's what I'm going to do. I'm going to subtract 25x from both sides. That way I'll have 0. So here's what I want to do. I've got 0 equals, and I want to put this, what's left, in descending order. All right? So I'm going to put that 9x squared first. I've got negative 6x, negative 6x, and negative 25x. And that's 37. So minus 37x. And then I've got plus 4. All right. The way that I go about solving this is I actually need to factor this. Okay? So this one looks quite complicated to factor using guess and check. So I'm actually going to use the box. My 9 goes here. My 4 goes here. And I need two numbers that multiply to 36 and add to negative 37. And that's negative 36 and negative 1. So I'm putting those in my box. My greatest common factor is 1. 1 times 9 is 9. 1 times negative 1 is negative 1. and 9 times negative 4 is negative 36. So here's what I've got. 0 equals x minus 4 times 9x minus 1. All right, so I factored it. Remember, these two things multiply equals 0. So one of these two things has to be 0. So our next step in solving this equation is to set x minus 4 equals 0. And I'm also going to want to set 9x minus 1 equals 0. And I'm going to get two solutions. So add 4 to both sides, and I get x equals 4. Here, add 1 to both sides, and I get 9x equals 1. Divide both sides by 9, and I'm going to get x equals 1/9. Now, I've got to check both of my solutions because I could have created an extraneous solution. So 4 is going to be easier. So when I do this, square root of 4 is 2, times 5 is 10. So this is 10. This, 3 times 4 is 12, minus 10 is 2. So that 4 is going to work. All right? Now I have 1/9. So here, let's write this one out. This one might be kind of messy. 3 times 1/9 is 3/9, okay? Minus 5 times the square root of 1/9, which is 1/3. So this is actually 5/3. All right? So this is 1/3. So 1/3 minus 5/3 gives me negative 4/3, not 2. So this is an extraneous solution. So I'm going to cross this one out. I'll write here that this is extraneous. It is not a solution to my equation. And this is why you need to check these when you're using this particular method. Now the next example we're going to do is a power example here. And most of your homework problems won't be like this next one, but it's kind of cool to see what you can do with this. So here's what we've got. And if you notice, I actually have two radical terms. Okay? It's okay. Here's what's going to happen. Let's go ahead and take this equation, and we're going to square both sides. Put this whole side in parentheses and square it. Okay? When we square this side over here, we get 2x plus 5. Over here, we've got a binomial, so we've got a FOIL. So let's do the firsts. Square root of 2x times square root of 2x is 2x. Times 2 is 4x. Times the other 2 is 8x. So this is 8x. My inners is 1 times 2 square roots of 2x. So this is plus 2 square roots of 2x. My inners are the same thing. 2 square roots of 2x. And my last 1 times 1 is plus 1. All right? So here's what I want to do. I'm going to actually go through the process of squaring both sides again. So I need to get this radical term by itself on one side. So actually, what I'm going to do is subtract 8x on both sides, and I'm going to subtract 1 on both sides. So I got those terms on the other side. So here I have negative 6x plus 4 equals, and when I combine these, I have 4 square roots of 2x. And now I'm going to square both sides again. When I do that over here, I've got a FOIL. So my first negative 6x times negative 6x is positive 36x squared. My outers is minus 24x. My inners is minus 24x. And my lasts, 4 times 4 is plus 16. And this equals, when I square this, my square root goes away. I just have 2x times 4 is 8x times 4 is 32x. All right, now notice I have an x squared term. I've got to use that skill I learned in Algebra 1 and get everything on one side of my equation so I have 0 on the other. So I'm going to subtract 32x on both sides. Here's what I've got. 36x squared minus, so I've got to combine all these like terms, 80x plus 16 equals 0. And now I need to factor this. Don't forget your factoring step of factoring out the greatest common factor, because when you go to use the box method, you're going to just make this a ton easier. I can factor out a 4 from here. So let's go to up to the top of the page again, and I have 4 times 9x squared minus 20x plus 4 equals 0. And now I'm going to use the box method to factor this. So let me draw my box. The 9 goes here, the 4 here. So I need two numbers that multiply to 36 and add to negative 20, and that's negative 18 and negative 2. So I'm going to put those in the boxes. My greatest common factor is 1. 1 times 9 is 9. 1 times negative 2 is negative 2, and 9 times negative 2 is negative 18. So this factors 4, and then x minus 2, and then 9x minus 2 equals 0. Now I've got these three things multiplied equals 0. This is not 0. So one of these two things must be 0 in order for this equation to be true. Therefore, either x minus 2 is 0 or 9x minus 2 is 0. So here I'm going to add 2 to both sides, and I get x equals 2. Here, if I add 2 to both sides, I get 9x equals 2. Divide both sides by 9, and I'm going to get x equals 2/9. Now, we have the difficult task of checking these solutions. All right, so on the left-hand side, if I put a 2 in here, I've got 4 plus 5 is 9. The square root of that is 3. On the other side, 2 times 2 is 4. The square root of that is 2 times 2 is 4. Plus 1 is 5. That does not work. So this is not a solution. This is extraneous. It does not work because 3 does not equal 5. All right? Now we've got to go back and check 2 9s. So you can see these problems get kind of long. All right? 2 9s. 2 times 2 9s is 4 9s. Plus 5, which is actually 45 9ths. We have to take the square root of that. When you add this together, we get 49 9ths. And the square root of that is 7/3. All right, so that's the left-hand side. On the right-hand side, 2 times 2 9ths is the square root of 4 9ths. So we've got the square root of 4 9ths, which is 2/3 times 2 is 4/3 plus 1 is 3/3, and that is 7/3. So this solution is the one that works. All right, so this is all the examples of radical equations. All right, how to solve an equation when you have x in the square root. Now the next examples that we have at the bottom of the page here are linear equations. They have square roots in the equation, but x is not in a square root. This, here's the good news, will not create extraneous solutions. Okay? It won't do that. So that's the good news. So here's what we're going to do. Oops, we'll get it on the screen. Get x by itself on one side. So in other words, I want all the terms that have x on one side. So here I've got x here and I've got x over here. Okay? So what I'm going to do is subtract x square roots of 5 from both sides. And here's what I have. 3x minus x square roots of 5 equal 2. Now here's the step that you have to take that makes this problem happen. See how these both have x? That's your greatest common factor. Factor x out as your greatest common factor. So x is your GCF. So bring it to the front, and you have 3 minus the square root of 5 left in your parentheses. Okay? Now, to get x by itself, all we have to do is divide by 3 minus the square root of 5 on both sides. So I'm going to divide by 3 minus the square root of 5 on both sides. These will cancel. Notice I have 2 over 3 minus the square root of 5. And we learned yesterday that I have to rationalize that denominator. I can't leave that square root in the denominator, and the way I do that is use the conjugate, which is 3 plus the square root of 5. So multiply by 3 plus the square root of 5 over 3 plus the square root of 5. In the numerator, I've got 2 times 3 plus the square root of 5. In the denominator, this is what I want to do. I want to FOIL. When I FOIL, I get 4. Okay? Remember, because every time I FOIL this, when I use the conjugate, all my roots go away. Now, 2 goes into itself once and into 4 twice. And that's going to leave me with this as an answer. So that 2 is going to cancel out with the denominator. All right? So actually, I think these are easier. These are the ones that students do seem to struggle with more, though. So let's go to B and we'll do this again. And remember, we want all the x's on one side, and we have that. Remember, x is our GCF, so factor it out. This is the key. X is the GCF. So bring it to the front, and in parentheses, I have the square root of 3 plus the square root of 2. And that equals 1. Now, to get x by itself, we're going to divide both sides by the square root of 3 plus the square root of 2. All right, on the left-hand side, these are now canceled out, and I have x equals, so I'm almost done. So here's what I've got. X equals 1 over the square root of 3 plus the square root of 2. The only thing I need to do now is rationalize my denominator. I'm going to use the conjugate of this, which is the square root of 3 minus the square root of 2. So multiply by the square root of 3 minus the square root of 2 over the square root of 3 minus the square root of 2. Okay, in my numerator, this is easy to FOIL. I get the square root of 3 minus the square root of 2. In my denominator, I have to FOIL. And remember, I know because I'm using the conjugates, the inners and outers are going to cancel. So my first square root of 3 times square root of 3 is 3. My last positive square root of 2 times negative square root of 2 is minus 2. And that happens to equal 1. So x equals the square root of 3 minus the square root of 2.